registration, please make sure that that's done properly. And then the last thing we wanted from you is this is something that you need to work with the other Shad, right? Not the trainer Shad, the other Shad and the programs team like Mukundan and so on. Make sure that you give me give the right name. I will ask them to follow up with you to get the right name, because we are trying to prepare some certifications for those who have attended and have attended 80% attendance or more. We are trying to prepare a certification to give in next 3 to 4 weeks, which would be the end of the Python session, right? To every one of you, at least the PDF format, we will send it to you in your emails. So we just want to make sure your names are without any errors, the names are actually printed in that certificate properly. So we will reach out to you to validate that your name is right. So when we reach out, please make sure that you respond to us. And this would be mostly applicable for people who have attended 80% or more the sessions. All right. Having said that, Mr. Saad, the floor is yours.
Great. Thanks, Radha. Can you guys see my screen?
Yep.
Okay, great. So in the session today, we'll be going over recursion, and we'll also do an introduction to classes and objects. So first, let's start with the exercise that I gave in the last session. How many of you were able to do it? What feedback do you guys have? Where did you guys get stuck? I would like to know your feedback regarding the exercise. I saw a few solutions and a lot of them were correct. And I'll go over one solution as well today. So any feedback on the exercise? Okay, so the libraries that I used for my solution were Spacey. Python standard library has a module called collections. I used that, and I used matplotlib. Now, a lot of people were having trouble installing Spacey. I did give a solution to that. You could use NLTK. That's another library that's a bit easier to install. And a big portion of this exercise was basically making you familiar with installing and exploring different libraries that are out there. So that was the real purpose of this exercise, and to give you a question which utilized multiple exercises. So this is my solution here. Let me just go over it and show you how it works. So first, we start with importing Spacey, and then we get a module for Spacey, which deals with English. So EN is English, right? From the standard library in Python called collections, we get a module called counter. This module basically just counts the number of elements within a object. So you can see the definition of counter here as well in PyCharm when I go over it. I use the open function to open the text of this file, and I save it in lines1 variable. Now, one thing I discovered when I opened this was that whenever there was a line break, I was getting this character in the text, and to remove it, I used the .replace function to replace this character or these two characters with a blank. So then I fed this data, which is the text in this document, to the module for Spacey that we installed here, ncore web small, that is right there. So now what we needed to do was tokenize the text. What that basically means is separate the text based on the words. Now, again, because we're using a library, that task is a lot easier for us. If you did it without a library, this would be a very difficult thing to do because you would have to deal with punctuation marks. You would have to deal with a lot of stuff like that. So we can just use, again, and these commands for Spacey I just got from their documentation online, right? So, there are a lot of libraries out there. It's not possible to remember all the different small commands. It's best to go look up in the documentation and see how stuff works. So what we basically wanted was all the text, right? But we wanted to make sure that it's not a stop word. Right? So we did an if condition here that checked if the token is a stop word, and that should not be true, right? So we wanted to make sure that we're not using stop words. So stop words are stuff like and or those words that don't really have a lot of meaning in a text. And we also wanted to make sure that the words that we're dealing with are not sort of like, or words or letters are not punctuation marks, right? So it's not an exclamation point or a full stop, for example. So we put those conditions in. And now one thing that I saw some of you guys missed on your solutions was that you didn't lowercase or uppercase all the words. Because we're looking for word frequency, and Python is a case sensitive language, it's going to assume a word with a capital letter at the start different from the same word where the everything is lowercase. So to standardize everything, I did uh, lower for X in words, right? So every word that we have now is lowered. Okay. Now another issue I was getting was that when we have a salutation, for example, Mr. Dot. Now, this dot over here was coming into the data. So the way I got rid of it was that I just looked up the last element of each word and made sure that it was not a period. Is everything clear up till here? Any questions?
I have a short question. I
Yeah.
thought you already got rid of the punctuations, and so shouldn't that have already dealt with the dot?
Yeah, so this was surprising to me as well. I thought spacey dot is punctuation would detect the dot with the salutation, but for some reason it didn't. So
Okay.
Mr. Dot, for some reason, it did not detect with this command. So when I saw that messing up the data, I had to do that manually here. Right, so this is just a check to see that this is a list, and it is a list. Let me run this as well before I continue with everything else. So then so here, we'll get to this soon. So yeah, I wanted to check what the type is of this, and as we know, it's a list. So now we initiated the counter, we put the counter on this list. And then we used we declared a variable called common words, and we used this, and we put 5 over here. It means that from this counter, we just want the top 5. Now, the benefit of the counter is that it arranges the words in descending order, right? So I know that just getting the 5 will be enough, and the 5 will be in descending order. And then I printed the most common words, and the type of the most common words is also a list. So this is me. Up till now, I've used spacey, and I've used collections module called counter. Now we're going to get to the matplotlib part. So just a question, how many of you were able to install all the libraries successfully? All the libraries that you wanted to use for this exercise?
Yeah, was able to install. I was actually trying to install this NLTK because Spacey didn't work out for me. This is Shri. So I tried with, as per your hint, I tried with NLTK, and then the map thing also got installed, right? Yeah.
Okay. So you were able to solve the exercise, right?
Yes, almost. But one thing which was missing was I didn't eliminate the punctuations using this NLTK. Maybe I would get into their documentation as you suggested, and I'll try to.
Yeah. I'm very certain that they also have a way of getting rid of the punctuation letters. And again, it's going to be slightly longer than the spacey one, but the functionality is there for sure.
Okay, sure.
Yeah. So doing a bar chart with matplotlib is really simple. Again, I didn't remember this, so I had to look it up. Right. So all you have to do is obviously import the library, declare that you're working with a bar chart, and inside the bar chart, you're going to basically on one side on the x-axis, you'll want to give the words. This is going to be X, Y, and then a few settings over here. There are a lot more settings that you can actually mess around with, and I encourage you to do that in your own time. So again, for the x-axis, I use this command to basically give it a list of all the words. So Holmes, said, man, little, come were given to a matplotlib as the x-axis. And then for the y-axis, I used the -1 index because I know that the quantity is in the last element of each tuple. I gave that as the y-axis, and then I was able to get this bar chart. And again, I didn't do many settings over here. You can actually, change the color, change the ticks over here as well. But this is a sort of a very simple way to get a bar chart done using Python. And again, you can move it around and you can get specific values on the side over here. So any questions about this exercise?
Hi, sir. This is Joy. In your comment, you said you gave us a hint and asked us to use vectorization.
Yes.
Can you explain what you meant by vectorization, please? Thank you.
So yeah, vectorization just means splitting up a text into something. So you could do vectorization based on sentences. You could do vectorization based on words. You could do vectorization based on letters even, right? So it just means splitting something up. In terms of what we're doing right now, it just means breaking down a big chunk of text into its constituent words.
So
then how is it? Oh, sorry, Joy. Yeah, continue.
So in this example, can you show me where you did the vectorization?
Yeah, it's right here. So you see these tokens? These tokens are generated after vectorization.
Does that mean that the tokenization and the vectorization are the same, or?
So again, you could right now the way Spacey is built in, if you do token.txt, it's going to be word vectorization, right? But you can go back in the settings and make it so that you do vectorization for sentences. But the default would be for words. Okay.
Yeah, got it.
Great. Okay, so let's start with today's topic. So we're going to start off with recursion, and then we're going to get into classes and objects. So recursion is based, and again, a lot of you already have probably some non-Python programming experience, and if you do, you've probably dealt with recursion before. But the purpose of this is to basically just show really briefly how recursion works with Python. So recursion really is very simple. All you do is you have a function that calls itself, right? So before I get into this, let me show you some really simple examples of recursion. So let's look at this example over here. So what this function is trying to do is basically, if you guys remember multiplication tables, it's trying to get the table for 12. So 12 times 1 is 12, 12 times 2 is 24, and so on, up till 10. So how can we do it using recursion? So we're going to define a function, call it table, and give it two inputs, n and I. Now, right off the bat, we're going to print the product of n and I. And I'm also going to, with each iteration, increase the value of I by 1. And then if I is less than 10, I'm going to initiate, I'm going to call this function. This function is going to call itself again. So let me show you how this is going to work. There we go here. These are the results. So how did we do this? So let's track each iteration of this function to see what's actually happening. So when we give it this and this, look at what's happening, right? It's going to print 12 during the first iteration because this line is running 12 into 1. It's printing 12. Then I is incremented by 1. So this becomes 2 now, right? And it just makes a check to see if I is less than or equal to 10, and then it runs the same thing again. Now, when it runs again, we've actually changed the value of I from the initial 1 to 2. So this function runs again and prints out 12 into 2. So we get 24 here. Same thing happens again, but this time I is equal to 3. This function runs again. We print out 36. So that's a really sort of basic example of recursion. Any questions about this? Or anyone who can understand this logic?
I just have one question. Like, I'm trying to understand how different is recursion over for loop.
It's very theoretically, everything you can do with the for loop, you can also do with recursion. The benefit of recursion is actually when we get into some really advanced topic of trees, binary trees, you can use recursion to sort of navigate over very complex data structures, right? So you might not find it useful right now for the problems that you're facing, but in the future, this will be important. And again, in terms of speed, it's slightly slower actually from a for loop if you do the complexity analysis of recursion. But again, at a certain point, when you deal with data structures and slightly more advanced algorithms, you will need to use recursion.
Okay, thank you.
Sure. And there are, yeah, sorry.
Hey, Sat, sorry. So this kind of, so recursion could be used for a search or like accessing elements in a binary tree.
Yes, yes, that's what it's primarily used for. But we aren't going to do binary trees in this class, but once you get there, you will need to know what recursion is, and you'll need to be able to identify its use.
All right. Thank you.
Sure. Any other questions? Okay. Okay, so now we're going to look at another example of recursion, but here, when the function calls itself again, it changes something. It changes the input or changes the argument. So what this is doing is I want a function that says hi a certain amount of times, right? Here's an example. I wanted to say hi 5 times. So first we set a base scenario, right? When n is equal to 0, you need to print end and to basically stop the recursive function. Else you have to print hi, but then you have to call the function again, but this time just -1 from n. And you can see that this is how it's working, right? So I wanted hi printed 5 times. It printed hi 5 times, and then n was equal to 0. This condition was met, and n was printed. We can check this by printing n here. There we go. We can see that the first time hi was printed, the value of n was 5. But then when we call this function again, we lowered the value of n by 1. Then we printed hi again, and we got 4 over here as the value of n, and so on until hi was 1. And then after we subtracted 1 from this, this condition was met and end was printed. End was printed. Were any questions about this? This is a sort of important concept. Where I just want to make sure that you guys understand how this is working, because then this is a slightly more complicated example of recursion. So Fibonacci numbers are basically, this is in number theory, these are a set of numbers that start with 0 and 1. And then each successive number is the sum of the preceding 2 numbers. So the next one would be 1. After that, we would have 2. Then we would have 3, then 5, Who can follow this logic and tell me what the next number would be for Fibonacci?
8.
Yeah. Right, so these are Fibonacci numbers. Now I want to make a program using recursion that will tell me the value of this nth Fibonacci sequence. So I want to basically be able to say, okay, what's the second element of Fibonacci? It's going to be 1, right? Fourth element of Fibonacci, it's going to be 2, and so forth. So this is the code for it. This only. So let's see what's happening here. So firstly, we set the base scenario, which is n is less than or equal to 1, and we return n in that case. So what this is going to do is basically going to return 1. Now else we're going to return the Fibonacci sequence of whatever the argument is, -1 plus that argument's and -2. Let's see this in action. So I use the for loop to basically run this multiple times, and we can see that I can print out the Fibonacci numbers over here. So to give you an example of how this is happening, I have this example over here. This is basic. This is for a different question. It's actually for your exercise question for recursion, right? So you can see the base scenario is returning something, then the scenario on top of the base scenario is returning something, and so forth and so forth. So it keeps increasing. So this is sort of a recursive trance that's opened when you make a recursive function. And once you do this exercise on recursion, which requires you to find the factorial of a number, you'll see this in action. Any questions about this?
I have a general question on this.
Yeah.
When I look at it's calling multiple times the same function, right? It looks like the performance is really going to hurt in case of recursion. Is there any alternative way for recursion to have a better performance?
You will only use recursion when you need to sort of navigate through, and realistically, you'll only use recursion when you want to navigate through a binary tree or some other kind of data structure, right? So right now, to do that, this would be the best way. And again, even though it looks slow, it's actually not very slow. It's just slightly slower than a for loop. So again, you would want to use a for loop instead of recursion when you can, and I'm sure this is something that you can do with a for loop as well, right? So if you didn't ask me to do this recursively, I would do it with a for loop. But again, this gives you an idea of how to do recursion so that it's useful to you when you actually need to do it.
Right. Okay. Thank you.
Sure. Okay. So let me also go over the question I have for you guys regarding this. Oh, here it is. Yeah, so all you have to do is create a recursive function that's going to find the value of a number's factorial, right? So factorial is, if you give 3, then it should be 3 multiplied by 2 multiplied by 1, which the output should be 6. So that's the only exercise for recursion. And again, this is how your sort of brain should work when you're thinking recursively. So you're going to set a base value, which is going to return 1. And then you're going to keep sort of going from there, right? And with each sort of iteration, you're going to return a value that's going to then be added to another value. And at the end, you'll get the answer. So I'd like you guys to try that out. Let's start with objects and classes. Before we do that, any other questions on recursion?
I have a comment, Saad, on the chat saying, can you increase your font size a bit so that it's more visible?
For this? Okay.
And one suggestion is you can zoom in the Teams as well if you're not able to view clearly, or it's too small. Even the participants can zoom. If they're on mobile, they can do pinch zoom. Otherwise, there is a zoom option on the Teams as well on the slide.
Yeah, I'll increase the size a bit as well.
Yep.
Hi, Sad. I posted that comment. The reason being, when I watched the video, it's not, the code is not very clear.
Oh, okay.
Thank you.
Yeah, is it better now?
It seems okay on my end.
Okay.
Can you try zooming in on your side as well? That's what I do. It helps me. If the screen is too small or the code is not visible, I zoom in at my end, and then it becomes pretty much clear.
All right. Thanks, Amit.
Great. So, so Python is a object-oriented language, and you know, we've up till now really worked mostly with scripting. So we write a Python script, we run it, and see what the output is. But the sort of modern way of programming is object-oriented, and you can think of objects as sort of like a collection of variables and functions that, and those functions act on those variables. Classes are basically just the blueprint of objects. So when you are creating an object, you call that a class, basically. You start writing a object by using the class keyword. This is similar to the def keyword that we use for functions. And again, when you want to create a variable and assign it to an object, we just use equals to here. So let's see this in action. So here I created a class called a dog, and I fixed a variable inside this class called species, and because we're dealing with a dog, I put the value mammal inside of it as a string. Now we're going to see some syntax that's new, but it's very simple. So the init syntax is basically just initialize, but because this function is defined within this class, we're just telling Python that when this class is initialized, do something with this. That's it, right? That's all the init function is. Now the first argument of the functions within a class is always going to be self. Self doesn't mean anything, but you have to use something over here, right? So it can be self, it can be any other word, but then again, we're using self here as well. And then we're going to give it the arguments, and then we're going to give it some logic for those arguments. Any questions about initialize over here? This is, yeah, sorry.
Question.
Yes.
Yeah. In place of self, can we use any other variable or any other word as well?
You can, but then again, whenever you use self, like for example, I'm using self over here and here, it has to be a different, it has to be that word. But again, the best practice is to use self. Okay. And actually, when you start defining a function within a class, PyCharm itself is going to make the first element self, right? So it'll do it itself. You don't have to do it.
Okay, thank you.
Now, once this class is initialized, as we can see, we want this logic to take place. So we do self.name, self.age. So it's basically asking for a name for the class and the age for it, right? And this is an example of me using it. So I create a class, call it first dog, and as a name, I give Jerry, and age, I give 8. And all of these are over here. And what self does is that it allows you to basically assign this name to this. And you can now access this information using a very simple syntax, right? Let me show you how that's going to work.
Just to clarify on this, I don't know who asked the question. Give me 1 minute, Saad.
Sure.
So self is basically when you talk about instance, it relates to the context of that instance, right? Uh, when we talk about classes, self, when you initialize something, self means the coming function, let it be init function or any other function containing self, will have that instance context, right? Uh, and also, init function is not necessary. Uh, it's basically to tell whenever you need to instantiate a class, you need to provide these variables. If not, then you cannot instantiate a class. It's not necessary. If you don't give the init part, it will still instantiate without any variables. Also, when we talk about the classes, you can remove self, but then it would become a static function, which is much more simpler, which is without context, and it will do whatever is desired in that function. I might not be clear at this point. I just want you to understand this theoretical part. When Saad will explain next, then you can relate to it. Thanks, Saad.
Right.
You can.
Yeah. So again, the reason we're having an init part over here is because we want, when we start with assigning starting this class, we want to compute sort of these inputs that are coming in. That's the only reason you would have init. You can perfectly also not have an initialization class, and then you can just uh, do something manually and interact with the functions manually within the class. So again,
Isabel, can I add something?
yeah.
Don't you?
I'm sorry, your audio isn't very clear. I can't hear you.
It's like in the function.
We cannot hear you.
Chat.
Your audio is not clear.
Yeah, I would recommend that you write down the question on chat, and then Summit can answer it for you.
Sure.
Hi, sir. As per my understanding, I guess the self is not a mandatory attribute, right?
Yeah, it's not mandatory. No.
Okay.
It's only when you have a function that you want to give a context to that function, then you need self. If you're writing a static function, then it doesn't need a self.
Okay, so what I want to do is basically, I defined first dog over here as class dog, and as name I gave it Jerry, and as age I gave it 8. Now let's say I want to access first dog's age, right? So I can just use dot over here, age 8. As you can see the output. That's exactly what I signed over here. So again, you could have any sort of logic here, any sort of different variables, and you can access them very easily using dot. And again, because we're using a really good IDE, I just do dot. It's automatically going to tell me what my options are. I can find it out the age, name, and I can also use this method over here, which is defined here.
Saad, for a static object, so the value must have been should be assigned in a different function, right? So
Sorry?
for example, this is here with this init function, you are creating a object by directly assigning a value. But for a static one, which does not have this self and this assignment, in that kind of object, you have to assign it separately in a function, right?
Yes, I'll show you right now. So all this is going to do is print Let's see what happens. So the first value over here will need to be the equivalent of self, but if you want something else,
Sad, you can avoid it by giving a marker called which is a decorator, right? Called at the rate static method on top of def.
oh, okay.
On top of def, add a decorator at the rate static method. Yep. And then you can avoid anything. Yep. That will work.
Yeah, so thanks, Sumit, for that. So here's an example of a static function implemented within a class. Okay.
Thanks.
So again, sorry?
No, I said thanks, yeah.
Yeah. So again, we had an object. We called it first. This object was a dog. We called it first dog, and we, as an input, gave Jerry an 8. And again, I showed you how you can access the name and age for this. Now, within this class, I have a function called print message. So what print message is basically doing is that it's taking the values for the name, for age, and it's also taking this variable here. And this variable is defined initially in this class. And then all this does is asks Python to print this message over here. So again, this is an example of another object that I assigned. But let's just focus on the print message. So I can use .print message to access this functionality. And what this is doing is it's taking the name for this object, which is Taz. It's taking the age, and it's taking the species variable, which is mammal. So now we can print this sentence over here. And again, we can use a loop to sort of iterate over both of these, right? Let me first make a list with these two. There we go. So we're using the for loop to access this function for the class dog. We've defined two objects, first dog, second dog, and we want basically these sentences printed out, which are being accessed over here. And to run this function, we access the name and age, which we assign over here using the initialize function. And in the initialize function, we ask the we can ask the user to give us a name and the age. Any questions on this? Again, we are going to have 2 sessions on classes and objects because this is an important topic, and we want to dig into it quite a bit more deeply. So any questions up till now?
Yeah, here's one question. This is Navina.
Yeah.
I just wanted to make sure that when you make those objects, first dog, second dog, and everything beneath those code lines, I would think that that is outside of the class you made up there.
Oh yeah, this is all outside of the class. So the class is just this.
Okay, roger that.
Okay.
Thanks.
This is just sort of interacting with the class that we've already defined. And usually what we'll have when we're working with classes, that we'll have one Python file which just has the classes, right? And when we want to do something with those classes, we'll actually make another Python file and we'll import those classes over there. So you can have all your logic and all your classes in sort of separate documents, and you can just access them in a different document. Any more questions?
Saad, just as Java would have constructors, is something like that valid in Python as well?
Sumit, could you answer that? Because I actually don't have much experience with Java.
All right. So the init function is similar to the constructor in Java. Uh, uh, and that basically what tells you that if that certain parameters are passed, how they are going to be used inside the class. So the init function is more also related to the constructor in Java, if that answers your question.
Okay. So would just like self, say, for example, we
So,
have two
so
parameters.
self is different than the init function. Self is more like a context of that class. So assume you have an instance of a class dog and it has a name, right? Now, when you're writing another function which contains self, it will already have the name of the dog in that function. So you don't need to add it again or get it from somewhere else. The name of the dog, that function will already contain. So the context is already there. So let's assume there are multiple. So there are 5 dogs and 5 selves. So each self will of each instance contains one name of the dog. So let me give a better. So there are 2 users in a shopping cart, right? One is in London and one is in LA, right? Now, when the two people from different countries are using the same class, right? They are having a different instance of a class. Now, their self will have the name of their individual location. Does that make better sense?
Yeah,
So
I got it.
the context is self, right? The class will the self will have the context of the class of whatever variable is passed. So here, if there are 2 different dogs, there are 2 different instances of the dogs. So each instance will have an individual name of the dog, which a particular function will have it for different instance, right? So you don't have to declare it again and again. It will already have the context of the class.
Okay.
Sumit, can we say that the self is like this operator in Java?
That's correct. Absolutely correct.
Thank you.
Yeah, so what would happen if we don't use self? Let's say if we assign these directly. Once I run these 2 commands, when I say dog Taz, I'll basically lose this information where with Jerry and 8, right? Because what I need to basically tell Python is that when I assign Jerry and 8 as a in the class dog, it's only for this variable. And when I assign Taz and H2 for this dog, it's for this variable. So what self is doing is keeping this information with the variable that you signed it to. That's another way to look at it.
So it's like, I'm sorry. So it's like without the self declaration, the previous instance of the class will be overridden with the new value.
That means you'll have to define, for example, you'll have to define the name or age or something like that as a variable over here, I'm guessing, right? So yeah, if you don't do it that way, then you'll have, no, you could define it again, right? So when you're saying dog Taz2 again, you'll have to write it down. That would be one way to sort of circumvent that issue. But to avoid writing it down again, we use self.
So I'll make it better in terms of, so right now, when you add another function to the dog, you don't have to provide the names again and again, right? But if you don't have an init class, right, and you don't use self, you have to provide the name and age of the dog again and again with every function.
Yeah, like you said, to avoid the repetition of this, to set a context already. Yeah, got it. Thank you.
Okay,
So,
great. Yeah.
Sumit, does this mean it's like similar to inheritance?
Uh, Inheritance contains more than this. It's part of inheritance, but it's not completely inheritance.
Yeah,
Yeah,
okay.
we'll talk about inheritance in classes in the next session.
Right.
That's obviously very important.
Thank you.
So can I say like this? For an example, the first dog and the second dog are the object of class dog, correct?
Yes.
Okay. So when you are calling the first dog and initializing the object of dog, you're passing two parameters. So when you're calling the object first dog is equal to dog class, you're passing those parameters, and the self's going to get the object name first dog. So it refers to that particular object and passing all over the places in the functions. So is that correct way of explaining?
So when you call the first dog again later in, let's say there are more functions that needs first dog, you don't have to provide these names again and again because it already has that context with it. If the self is not there or the init class is not there, then again you have to provide the name and age of the dog again in order to do anything or to fetch the name and the age again.
Okay. Okay.
Great. Any more questions?
Yeah, this is a difficult concept, but Python is basically based on classes and objects. That's a must if you want really need to jump into Python programming. So try to understand this concept as best as you can. And even if you have questions that are not related or you think you're repeating the questions again and again, ask today, because this is really the crux of Python.
Okay, I do have a question regarding classes. Let me share that. So for this exercise, you're required to create a Python class named circle. And within that class, you'll have two functions. One of them will calculate the radius of the circle. One of them will calculate the area of the circle, and the other function will calculate the perimeter of the circle. And the input that you'll take will be the radius, right? So your init class, when you initialize it, your init function, when you initialize it, will ask for the radius of that circle. And then you'll have two functions that can compute the area and the perimeter. This should be fairly straightforward because you already have the sort of code for how to do a class, right? So again, when you just to give you an example of how that exercise fits in over here, when you initialize a class named circle, you're going to take the radius over here. So you'll have self, and here you'll have radius. And then you'll have two functions over here that will then calculate the area and perimeter. Does that make sense?
Yeah. Yeah.
Okay.
I think, Sal, we should stop here before people get overloaded. We might repeat once again what we have told, summarize it so that they better understand, and then they can work on the exercise.
Okay. Yeah. So again, let's take more questions then, because basically we want everyone to understand this logic here, right?
Correct.
So I want everyone to basically just look at this and see if they have any questions right now, and then attempt the exercise that I've given.
Sab, is regarding a general context of Python. So object-oriented nature of Python is like optional, right? So
It's the way Python programming is done, right? So when you use a library, for example, that library, if you look into the code of it, it's all classes over there. So that's sort of the way we do Python programming. You can do scripting, right? Where you don't use a class and you just focus on like small scripts, but real Python programming is object oriented. And I think Samit has experience with that. He can also elaborate.
I'll add to this. Scripting is when you're doing any personal work where you don't intend it to be used by multiple people, right? But whenever you go to any company or enterprise solution, it's always the object-oriented language that we use so that people understand it better. It's not one person working on the whole project. There are multiple people working, so it becomes much more simpler to reuse those classes again and again. So you don't have to write code again. When you do scripting, you only do scripting considering you're not going to write that code again. But when you use classes, it's basically the reusability part because you are going to use that object again and again in different contexts or in different uh, logics, right? So you need to make sure that you make your work less burdensome. So classes and object help you do that. So this function, that is associated with the class, you don't have to write it again if you're doing object-oriented programming. But if you're doing scripting, the same logic, you need to write it over and over again if you're calling it multiple times. Does that make sense?
Yeah, so I got that part. So in industry, you have to have like objects built on it for better management and accessibility. But my question
and also
was
reusability. That's the major concept. So you don't have to write it over and over again.
Yeah, reusability is the most important thing. But my question was on a different aspect. It's like, so Python, we can script and we can use objects. So it's like, it's not strictly object oriented.
Yeah, it's not strictly object oriented. That's correct.
Yeah, all right. So I was just like trying to compare it in terms of Java just to understand.
Yeah, Java is strictly class-based, but Python is not. We can write, it's a mix of functional programming and OOPS programming. Functional programming is basically you write a function and you execute it. Even if you don't write a function, just write like a script and run it, right? It's an individual file, just say print hello and execute that file, it will print hello, right?
Yep. All right.
It's more like a runtime programming language, which basically gives you the flexibility. But when it comes to any enterprise project or any personal project as well, it's always going to be object oriented because you don't want to be redoing the same work again and again.
I mean, it's not only that, right, Sumit? I'm just sharing my experience, right? So structural programming, you can think like our grandfathers in our parents' era, right? Object-oriented programming is our era, right? So why every enterprise nowadays, no enterprises does structural programming anymore, right? Everything is object-oriented programming. Why?
Yeah, not really, Kader. Functional programming is gaining more traction in terms of smaller projects for any operation project or any
internal projects, right?
Correct.
But I'm talking about really enterprise application, external projects, and moving forward, all those microservices, everything, right? It falls under this. Okay, let's put it like this. Not maybe my wording was incorrect. Not all, but most of all the products that are done is object-oriented programming, right? And why? It has got like what Sumit was saying. You can create an instance and you can reuse the code. Yeah, you can do that with classes and objects. And you can also do that with functions too, right? You can write a function, you can reuse that function in many different places. But what's the major difference here is that my view, right, is when you think about a practical aspect, right? So you have a car, and there is a model of let's say a company has a car, let's say a Hyundai, right? But now Hyundai has Santa Fe, and then in Santa Fe you have multiple different models. So what happens is that's one thing, right? And then another thing is whenever security aspect of it, right? So in the class you embed the variable and the function within the class. So the variable can be most of the time modified in a good programming language through the functions within the class, right? So you are also protecting the data. So these are the two key aspects, right? So by creating a class, you are able to define one and address multiple flavors of it, like, Santa Fe, this model, that model, this model, that model. And the second thing is security aspect of it, right? So these are the two key aspects, I believe, which was the driver, because it's more aligned to the day-to-day life of ours, right? So any data that we have, it has multiple flavors, right? A computer has multiple flavors, a GUP has a multiple flavors, so defining one to address all the multiple flavors is what the class and objects allows us to do. So the class is nothing but a template where you write the code. Object is nothing but an instance of that particular class. So you have a Santa Fe, you write a class called Hyundai Santa Fe, and then you can create an object for that class saying Santa Fe XL model, right? Santa Fe M model, Santa Fe P model, or whatever. Right, so the object becomes the instance of the class, and it allocates the memory where you can store the variable and operate on that variable through the functions within that class definition, which becomes an object, right? So does it make sense? Did I make sense, Sumit?
Yeah. A little complex, but yes, but that's how it is, right? Uh, I guess the main part is, as you go further, as Saad will take one more class and you practice within your domain, you will try to see the benefits coming out of the classes, right? And that's how the industry is practicing right now, right? So it's not only Python. All the languages are object oriented, most of it. Even if the functional programming language that is coming up in the market, they also tend to follow the OOP structure as well.
Hi. My question is, can we assign a list in place of class attribute?
Sorry? List?
Can we assign a list in place of class attribute? Like suppose right now it is a string as a species.
This is not a string.
No. What he means, the variable defined inside the class. Class,
you
right?
can.
So yeah,
okay.
any type of variables you can define, I guess.
Yeah, you can define it as long as your functions are compatible with that, right? So for example, if you print something over here, and this function doesn't support a string, then it won't work. So you need to make sure that whatever you're defining it as is compatible with the functions.
Okay.
But it will accept it anyway, right? You'll only get an error when you run that function.
Yeah, okay.
Hi, sir. Can you please explain the species equal mammal in a real life work example? So species, is it a keyword?
Species is a variable which has the value mammal, right? Because this class is a dog, I'm showing you that when you're defining a class, you know that this variable is going to be this. So whichever dog is defined over here, the species for it will be a mammal, right? So you don't need a user to write mammal over here. That's why you don't take species as an input from the user.
Okay. So this is just not, what do I say? Not Python, not
Python defined.
Not Python defined.
No, this is not Python defined.
Yeah, if you go back to that Santa Fe thing, right? You can define here class, I don't know, car, and inside that you can say, a variable which is
I can say like
seat,
car,
leather,
right?
seat, leather, leather, whatever, right? And then you can write functions to operate on that variable, right? To add, delete, whatever.
Number. I'm just trying to think of a real life example.
So
example like work environment, right? If it is mortgage, we can say personal loan, commercial loan, something like that. And then we pass the account numbers into this application, through the object to the class, and then you do some processing. Is that how it works?
No. So when you say, let's say it's a checking account, you're passing it as an init, right? That you're asking to get the attributes of the checking account. And now when you go into the class attributes, it's mostly a variable associated with the checking account. Say that checking account should have 2 checkbooks, right? So when you go into another function, let's say you are an operator trying to search how many checkbooks a checking account can have, right? So what he will do is, as a coder, what I will try to do is, I will say, let's take the example of the dog, right? First dog dot species, give that print information to the operator, which it will come to a memo, right? Or a bank account dot checking dot total checkbook count, get that information to the operator. That will be 2, right? So the real life situation, it's basically I'm trying to get some information from that class, right?
Okay.
So as an operator,
So,
I'm looking, a customer is coming asking, I need 3 checkbooks, but I'm not sure. So I'll go into it and I'll search that how many checkbooks a checking account can have. And I will get the information as 2, which will come from this class.
So when I say here species equal mammal, so I'm going to have more information here, right? In real life. So here we have, right,
You will
okay.
have tons of attributes that you will.
Okay, so that is, okay, the attributes are defined here. So it's like reference fields kind of, right?
That's correct. So you can say species mammal, total legs 4, 2 eyes, 2 ears, right? So those kind of attributes was associated with a particular instance of dog, right?
Okay, so the attributes are defined here, the preconditions rather. If it is,
it's more like an information.
Information. Okay,
it's a variable. It's a variable that you wanted to store the data.
Right.
Yeah, the class attributes that you define here will be valid for every instance of this class, right? So the species mammal is going to be true regardless of what this is or this is.
Okay, so one criteria, the criteria is defined there, right?
So let's assume you have a dog class and then you have a cat class. So cat class will have different attributes.
Right? Yeah, correct. Yeah, okay. So account type, privileged customer, right?
Right.
We put all the criteria there. Okay, got it. Okay, thank you.
You know, Shad, when I was learning this a while ago, my teacher kind of said, class is a, just correct me if I'm wrong. Class is a definition, right? It's not, it's a definition where you define the variables and the functions that operate on that variable, right?
Yes,
so it's a definition where you write the code. And if you wanted to create an instance of it, then it becomes an object. So like, for example, if you create a class here, which is a dog, and then if I want to create an object, I have to create an object, which is what exactly allocates the memory for all the variables that you have defined, which is attributes, and the functions that are required to operate on those variables. And then it has its own memory space and it works on that particular stuff. And you can create number of classes and inherit them, polymorphism them, or whatever, right? But is that right way of saying it?
Yeah, that's accurate.
Okay.
For most of the languages, Python is mostly a runtime language, so it compiles a lot of the files at the runtime itself. So it will already allocate those variables in the memory before you try to execute. That's why Python is always slower than Java. The reason is that it's a runtime compiling language.
Understood. But that's okay. But still, object is the one which allocates. Class is just a definition, right? By writing a class, it's not going to allocate any memory, right? Once you instantiate the class, then you will have a memory to play around with, right? Is that right, Sumit?
In Python, it actually does allocate memory to the classes as well.
Okay.
So maybe what I see is like,
whatever compiles in the runtime, it will have to store all the values in the memory itself, and then it will try to execute that. So in a way, the theory is correct, but how internally it processes is different for Java and Python, right? But mostly the theoretical part is correct. It's basically applicable to all languages.
Okay, that makes sense. Yeah, I think it's good. So coming back to Joy's stuff, bank, I like that account bank, right? So you can create a class called bank, and then you can put inside, the account name, account number, whatever you want to define. Those you can define as an attributes, and then you can write functions to operate on those attributes to initialize the values and fetch the values or modify the values or whatever. And as a definition in the class, and then you can define an object, and then you can say Bank Montreal, right? And then have a list of stuff, bank, I don't know, TD, have a list of stuff, something like that. Is that, am I connecting to what Joy was saying to what our understanding is, Shad?
Yeah, so in that example, when you have a person, that person's information will also be in a class itself, right? So you'll be dealing with multiple classes there. So you'll have a
class
class
within a class.
Yeah, you'll be dealing with a class named person, and then all of the person's information, date of birth, nationality, stuff like that will be saved within that class, and you can again have logic on that within that class as well.
So I want to add one more point.
Sorry, Jai, just a minute. Just want to clarify that with Shad, right? So I understood that, but that's totally depend on how the programmer and the use case that he needs to define the class,
of
right?
course,
I mean, it's not a written rule that this is how we need to do, but it's the logic of that particular program that he wants to write. He can either define a class, which is a bank, or he can define a class, which is a person, and whatever, right? Is that understanding right? Okay.
Yes.
Sorry, Jai, go ahead, please.
So like if we look at select a customer, so select this blah, 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 attribute 1, attribute 2, it's all defined here, I guess. Undesirable customer. How do we process? Then from there, you go into different functions. Like you say, CADA. So like Bank of Montreal, if it is undesirable customer, I'm looking at a real life example, right? So undesirable customer, or like, do we send him those delinquent notices? Like I get the concept now.
Yeah. Could be right. It could be a function which determines based on the input parameter that you pass what to do with that customer, meaning what to do with the attribute variables that you have defined. It totally goes with your logic. But from the concept point of view, I think we are in sync. Yeah.
Yes, I think this is a good conversation. Like if we can match it, like we learn the concept, but also match it with a real life example, it brings more clarity. Thank you.
Yeah. Sure. And so that's why we have kept this time for question answer and to discuss rather than talking more about more context or concepts. Let's clarify this once because this is very important. So I have another question from the chat, Saad, which says how to avoid unexpected indentation errors.
So again, PyCharm is very good at identifying those errors, and you should really follow these guides that PyCharm has to fix those. So the errors that you get within PyCharm will let you know if there's an unexpected indentation, and you can follow these lines, these underlines, and to find out where those issues are occurring. So I would to that I would say you just follow the instructions of the IDE that you're using.
And there's another option called format document. So if you do that in PyCharm, it will automatically fix those errors as well for you.
So is that a library we have to download, the document?
No, it's a PyCharm feature. So you can look for it on top. I forgot where it is, but there is a code format somewhere. Format code.
Okay, I haven't seen that before. I'll look for it and
I think it's in the code. Go to code, reformat code.
Right.
Is it this?
Yeah. So it will take away most of the errors.
Okay.
I have one more question. So for the object, instead of typing the data in terms of testing, can we pass a spreadsheet? So when it says dog, Jerry, 8 years old, like can I have a spreadsheet and have multiple data?
That's correct.
You can.
Oh.
For that, you will need a library to deal with the CSV file or the Excel file that you're using. But yes, it can be done.
So that will be one argument. The spreadsheet is going to be an argument.
Before you reach that scenario, you'll have to extract the data from the spreadsheet.
Move it to a table or something that Python can understand.
Yeah, you'll probably be doing using pandas for that. You can look at the documentation for pandas in regards to processing information from spreadsheets.
Okay, all right, thank you.
Great. I think that covers everything for today.
Yeah, great conversation again. Good session, Sumit and Shad.
Great.
Any other questions are there? Keyboard shortcut for formatting the code. So Nevena put some input to you guys. Shortcut.
Oh, okay, great. I'll have a look at that.
All right, perfect. Good work, and we'll see you guys. Shad, I just have a question. I mean, we just have another three sessions or more, so you should be able to cover the basics by then, right?
Yeah, we'll do one more session on classes where we'll really dig into the details. After that, we'll do 2 sessions where it'll just be projects or exercises.
Okay, so I just wanted to, obviously one criteria right now we have is to give the certificate is the attendance. We'll figure out 70 or 80%, whatever. The other aspect I want to also give an option to the attendees who joined late and they could not attend all the sessions because of personal reasons or whatever. Can we have some kind of quiz and some criteria pass percentage on that quiz in our last, one before last session, to kind of give an opportunity for some of the attendees who do not have an attendance also can get the certificates?
Yeah, definitely. We can put together a quiz.
Yeah, a simple one, right? Not necessarily they have to, not necessarily concept quizzes, not necessarily.
Yeah,
coding,
MCQs
right?
basically, right?
Yeah, exactly. 15 to 20, and then we can probably, allocate one session, because last session we really wanted to spend 30 minutes of the last session to provide the certificates and thank you or whatever, right? So one before last session, if you can do that quiz, would also give an opportunity for those who did not have an attendance to get the certification.
Okay, great. Sounds good. I'll put that together.
Okay.
Perfect. More than that, yes, it will be a better idea if that's possible. Let's base it on the projects that we are going to do now, right? So that will be a better understanding of how much they have understood, rather than just a quiz.
Okay. I'll leave it to you guys, right? What I need is, from the principal point of view, I wanted to give an opportunity for those who do not have an attendance, right? 75 or 80%, an opportunity to get the certificate through this. That's my thought process.
Sure.
Okay.
Great.
All right. Perfect.
Okay. Thanks, everyone.
All right. Thanks, everyone.
Yeah, there was some question. Attendance is attending the sessions, right? Not during the session. Like we have done probably 15 sessions. We will look at how many sessions you have attended, and we will come up with some kind of criteria. We haven't decided whether it is a 75% or 80%, but the point is we won't go below 70%, right? Then it does not make any valuable sense, right? 70% or 80% we have not decided, but when towards the end of the session we will look at it, how many people are falling under which category, and then we will decide. So that's criteria number 1. Criteria number 2 is through the trainers, through the projects or quiz, if they recommend someone, then yeah, right, based on the criteria that they set. These are the 2 criteria we are having now. Just because we are starting with this, but eventually in the second session, third session, we will refine, and maybe we will bring up some more organized way of providing the certification with some criteria. Okay, Naru, you got the answer, right? Perfect. All right, let's close the call, guys, for today. Great work. Bye.
Bye.
Thank you, Sad.
Thank you. Thank you all.
Bye.